welcome back. And here we go. All right, open to suggestions right now. Anybody?
Dr. Whitaker?
Yep.
So we have talked a little in the chat with the other students. Can we do one of the Lewis structure for one of the long organic molecules, how to draw them, how to attach the groups?
Sure. Do you have a specific one in mind?
Yes, we have Spring 2018, question 2, part
Okay,
2.
got it. I'll go find that right now. Spring 2018 to big molecule coming up.
You have mentioned that it's going to be like half of the size, but
Yes.
still it would
So
be nice.
if we can do the big one, we can definitely do the smaller one.
Yeah. And the next question depends on it, so we definitely need to get it
Okay.
right.
Yeah. Oh yeah, they're huge. That's a big part of your test. I just got to get it. There we go. Spring 18, I think. Yeah. Sorry, not seeing any of this yet. Here it comes. I'll just grab the molecule and then we'll go from there because you know all the words. The words are identical to the one on the test. I got the wrong thing open here. All right, finally. Here we go. And we're over here, so you'll be able to see this. That's the one, right? And make it big.
Yes, correct. This one.
All right. Okay. So we're supposed to do a Lewis structure. Now, the way I approach this is I look for some of those short forms for functional groups I know, especially if there's a CO2. You know, that's one of my favorites, right? If there's CO2 in the molecule somewhere, and CO2 is going in this direction, and on the left, there's a CH3. You guys know that's called a methyl now. So I'm going to start there. CO2 going to the left, not to the right, means the carbonyl is on the right, and the O points to the left, and we got a C with 3 H's. And don't forget, this is Lewis, so you're not allowed to leave lone pairs off. Oxygen's nature is to form 2 bonds and have 2 lone pairs. So when you're doing Lewis of oxygen, make sure that happens. And then I'm just going to take it one atom at a time until I get to the end. Now I've got a C with 1 bond to H. So that's that one. That goes to a C with no bonds to H. So I've got that one. And then a C with no bonds to H again. All right, so I'm up to here, but there's this group off of the C I just did, and that, I've had students ask me, is this late in the game too? How do I know if this is a carbonyl or an ether? And the only answer is, can you get an octet to this carbon with a carbonyl? And no, that can't be a carbonyl. This one can't be a carbonyl, because if it's double bonded to this O, you can't have this O also bonded to this C, that'd be 3 bonds. So up here, I'm doing O with a CH2, CH3. And I'm back to this carbon here. And I'm thinking it has to go to a C over here. Once again, this was sticking off, so make sure it's sticking off. It's not in the middle, like it can't be in the middle if there's parentheses around it. So you're going to the next CH2. Don't worry about pi bonds on carbon yet. Do those at the end. CH2 to a C with no bonds to H. So I'm here to another C with no bonds to H. Okay, to a C with a bond to H. And off the same C is an NH2. Nitrogen's nature is 3 bonds, 1 lone pair. Please know that forever. Then to a C with an H. I don't care if the H is up or down. Sticking off of that C, that's another pattern I'm supposed to recognize. CHO is always carbonyl, H, double bond, carbonyl, lone pair, aldehyde. And now how do I know this is a carbonyl and not a single bond to O and a single bond to N? Because to get a full octet, you'd need double bonds to O. O would have more than 2 bonds. O would get a charge. This carbon needs a full octet, so it needs 2 bonds in there. Goes to an N with a bond to H. Goes to a C with 3 bonds to H. And there you go. And there's one problem with the O over here. I forgot O's nature for a second. And the last thing I always do is always for dessert, whether it's nomenclature or this question, pi bonds on carbon. This carbon has only 3 bonds showing. It can't go to the left, can't have 5 bonds to this carbon, must go to the right. That took care of the octet on this carbon right here. It did not finish off the octet on this carbon here or this carbon here, and that would require a second pi. And now going over here, this is fine. You can't go double bond left, got to go double bond right. And apparently that wasn't enough because this carbon doesn't have an octet, this carbon doesn't have an octet. One more time, and yes, we have a triple bond. And everything else is full octets. Save all this fine work. Okay, please only draw the molecule once, even if it's half the size of the original. It's still, I don't want you wasting time copying out molecules. Functional groups, I believe was on the test. It's going to be somewhere on your test, even if I don't believe it's on this question, but you'll have another drawing like this on the test with functional groups. So let's review them. You're allowed to call this an ester. Most of you know it's more specifically a carboxylic ester, but that's the default ester if there's no other words. No carbonyls on either side here of an oxygen. That's an ether. And we have an amine here. Now you want half credit, just write amine. Nobody wants half credit. The nitrogen has one bond to carbon. You write primary amine. Okay, and we have aldehyde here. Now, nitrogen attached to carbonyl is not an amine. You get 0 points if you write the word amine. I don't care if you classify it right anymore. That's an amide. The nitrogen has 2 bonds to carbon, so it's a secondary amide, DE. And then we're supposed to do the big points for labeling every bond and telling me what kind of sigma it is. And then when you're finished with sigmas, you can do your pi's. All right. Every sp3 atom attached to hydrogen, give it the same label. There are a lot of them. A. Okay. Maybe I can save time myself. I don't know. I sometimes get in trouble. Things get huge.
Dr. Whitaker?
I think writing them's faster. Yes, sir.
You see where you put second degree amide?
Yes, I do.
Isn't it supposed to be amine?
The nitrogen is attached to a carbonyl, which makes it an amide.
All right, I see that.
Yes, a nitrogen attached to a carbonyl is an amide. A nitrogen attached to a carbon that is not a carbonyl is an amine. And we're finishing up our A's. I can't put an A here. This is not an sp3 carbon, but I can put an A for all of these. A. And yes, here. Wait, that's not carbon, but it is sp3 hybridized nitrogen. There's a ton of those. Now, You don't get any points just putting labels. Those are all sigma bonds. I need to see that letter. Sigma looks like a eyeball with a hair or something. I don't know how to describe it. Sigma between an s orbital on hydrogen and an sp3 hybrid on, in these examples, carbon or nitrogen. And my personal preference is to get the H's out of the way. You can just go left to right if you want. I do not mind. I have, what, 2 B's in this molecule? Those are hydrogen attached to sp2 hybridized atoms. Once again, sigma, S from hydrogen, sp2 on the atom attached to it. And then I'll go left to right. sp3 to sp3 there. And sp3 to sp3 here. sp3 to sp3 here. sp3 to sp3 here and here and here. Both atoms in the sigma bond are sp3 hybrids. And then D, sp3 on one of the atoms, and the other atom is sp2. And that's, this one's not, that's 2 sp2s. Here's an sp3 on the top, sp2 on the bottom. Here's an sp3 to the right and sp2 to the left. Don't do it here, that's an sp on the left. Here, sp3 left, sp2 on the right. sp2 remains, I haven't labeled that yet. sp3, oh yeah, sp3 on the bottom, sp2 on the top. And all the D's are done. And if I find one later, I'll just put the label on. And E, the sigma bond here is an E, sp2 to sp2. Don't forget, hybridization of an atom with 1 sigma and 2 lone pairs, that's 3 fingers. Sigmas and lone pairs is what you count. 3 sp2s in the name, sp2. And that's E, and this is not E because the middle atom's sp. These are both sp. We have an E here. And another E for this carbonyl here. And we don't have any carbon-carbon double bonds that are all by themselves. That would fit too, but they're not here. sp2 to sp2. And F, just keep going. Sigma's first. You want to go do pi's out of order, that's fine, I don't care. Oh, that was an E. I missed that one. sp2 on the left, sp2 on the right. So this will be F. sp2 on the left, sp in the middle is the same as sp2 on the right, sp in the middle. And there's no more F's, I'm pretty sure. There's a G. G, let's see, sigma, G, and another G, sigma sp on one side, sp to sp3, and that's sp3 here, and sp3 here. I think we're done with G and H. That's a sigma between 2 sps. And are all of our sigmas. Now I have an sp2, sp3 I missed. Thank you for patiently waiting for me to label this as D, because it's sp3 here, sp2 there. That's the name in D. And I, it's time for pi. I'm skipping that other pi, and I, pi, py, and I will go slowly with this explanation of why this cannot be called I as well. When you use the py orbital to make a pi bond with the py orbital here, the py orbital on this carbon is now used. You cannot use an orbital more than once. You must use a different p to make the other pi. It needs a different name. We'll go J. Pick anything but Y. PX, PX, fine. PZ, PZ, fine. Make sure they match. And the second one here, you can go like this. That's a comma and a J. And I didn't do this with pi here. Call it I. Could call it J, doesn't matter. Bonding is done, unless I missed a letter. I don't think I did. And moving on to geometry of central atoms. Can I get it in this little corner over here? Sure, when you make the corner bigger. Oh, cheater. Okay, I'm going to go with capital letters for this. As long as your labeling's clear, I don't care how you do it. sp3 carbons with no lone pairs. Well, sp3 carbons not going to have lone pairs. Oh, can I sneak an A in here? I need the name of the geometry, and that's a tetrahedral. And I need its bond angle. 109.5 degrees. And I'll just move left to right till I'm finished. And oxygen, that's sp3, always has the same geometry. It's called bent, and it's sp3. I only want one angle for sp3. And I skipped the letter C because a capital C looks like a lowercase c, and it also looks like carbon. You can use the letter C. I do not mind. I will figure it out. Trust me. We got D's. We got a lot of D's. And a D here. That is trigonal planar. I will accept this short form, especially since the planar is redundant after you write trigonal. Trigonal planar is sp2, so the angle therefore is 120. And we need an E and an F. Yeah. I don't need the question anymore. I got my molecule. E would be for nitrogen. Is there an F? That's a good question. We'll find out. E, the nitrogen. Yeah, and there's another nitrogen here that's sp3. And it's not tetrahedral because one of the corners is a lone pair. We call it pyramidal. Yeah, I do need an F, don't I? Pyramidal, 109.5 degrees, and F is linear. 180. And that's these two and one more in the middle of this thing. And that's an F. Terrible looking F. That's fine. I missed a tetrahedral carbon I see right here. Thank you for patiently waiting for me. And I missed another one right beside it. Wow. And I'm just looking at all my atoms that have more than one thing attached, and they're all labeled with a capital letter B, A, F, F, A, D, D, E, A. And that's that. I believe that's the total there. And do you have any questions about that, or you have another question you want to move on to? We're out of time, but I think that was a good finish. Don't you? I think so. So I'm going to work my best at posting these within the hour, because I know you guys are studying, and it's like we're on last minute studying now, so everything's critical. So I'm going to try to do that. I do have a check-in coming up in 15 minutes, so I'll just be renaming files before that, and then we'll go from there. And I'll see you Wednesday, a few minutes before your exam. We got a question. Yes.
Can I use this to do the exam?
No, you have to write on paper. I'm sorry.
On actual paper?
Yes.
All right, thank you.
So you only need like 4 or 5 pages. Yeah. Study that. Protocols, whatever it says, very carefully. Yeah.
Gotcha. Thank you so much.
All right.
I have a question.
Yeah.
About the structure, you were saying the nature of oxygen is 2 bonds and 2 lone pairs.
Just think
and
of
the
water
nitrogen.
every time. Yeah. And
Yeah.
now nitrogen, think of ammonia, NH3. There's 3
And
bonds and there's a lone pair. Yeah.
you can never break that rule, right? When you're
Not
drawing.
unless you have ions, and this question will never have any ions. I
Okay.
promise.
Okay, thank you.
Okay. You're welcome. All right. With that, I will stop and render and see you on exam day. If you have good questions, please send them to me, and I will make sure everybody gets the question and answer. All right. And I'm going to try to work on my emails a little more. Okay. Take care, everybody.